In this video, we're going to learn some trig derivatives. We're going to start out with sine of x and cosine of x. Now, I've already filled in some of these graphs just because they're a little difficult to draw in real time, but we will try to draw some of them in real time. So let's start off on the left with sine of x. So if our function is sine of x, then the rule is that the derivative is cosine of x. Okay? So let's draw some tangents on sine of x. So this top graph is f of x equals sine of x. Okay? Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. And sine of 3 pi over 2 is negative 1. Okay, so tangents at these points. The tangent at 0 looks like a 45-degree angle, right? That looks like 1. Okay, so we fill in 1 here. The tangent at pi over 2 looks horizontal, right? So it looks like 0. Fill in 0. The tangent at pi looks like the opposite of the tangent at 0. Looks like negative 1. And the tangent at 3 pi over 2 looks like 0. Right? So let's draw in between these points. Okay. And then we know that this will be symmetric. Right. And that's exactly the graph of cosine of x, right? So we knew that the derivative was cosine, so we could have just drawn in the whole function, but it's good to map in your mind what the slopes look like to the function values below. So yeah, we typically draw the function, and then below it we draw the derivative when we're learning these things, because it kind of helps to do it that way. Think about the function up here, think about what the slope is, and then that's the value you get on the graph below. Slope of 1, below on the graph you get 1. Slope of 0 here, you get a function value of 0 here. Okay, so the derivative of sine is cosine. What about over here? What if the original function is cosine? That's what I have drawn here. Then the rule is that the derivative is negative sine. Okay? So f prime of x equals negative sine of x. So this time we'll just draw in negative sine first. So negative sine, you take the sine curve and you flip it. So it goes down first, not up. It looks like this. Right? That's negative sine of x. Now let's draw the tangents. So at 0, looks like the tangent is 0. Okay, that checks out. At pi over 2, looks like the tangent is negative 1. At pi, looks to be 0, and at 3 pi over 2 it looks to be positive 1. Okay, so we can see the connection between the slopes and the derivative graph, right? So the derivative of cosine is negative sine. Let's practice these derivatives. Let's see what happens if we keep taking the derivative of sine of x. Okay, so f prime of x, we just learned that the derivative of sine is cosine. And if we take another derivative, we know that the derivative of cosine is negative sine. Okay, if we take another derivative, then we know that this negative sign, we can ignore it for the derivative, and we just take the derivative of sine. So we leave the negative sign, and then inside parentheses, the derivative of sine is cosine. Okay, so I will rewrite that here. The third derivative is negative cosine. Okay? And then if we take the fourth derivative, again, we leave the negative sign alone, and we take the derivative of cosine of x. We know the derivative of that is negative sine of x. So I will rewrite that here. Negative times negative is positive, so we are left with sine of x. So, if you start off with sine of x, and you take 4 derivatives, you get back sine of x. That's kind of interesting, right? If you keep taking the derivative of this function, you'll get back to the same function.